Okay, so we're doing this problem just to show how the frequency of compounding makes, or the higher number of periods, how the future value, how the present value changes. So we have no future value, nothing left, and we will be receiving over 5 years, each of the next 5 years, $100. And the question is, how much is this annuity worth for you if you can earn 10% interest? So we just do 10%, 5 years, payment, future, and again here for type, it says ordinary, so either you can put 0 or you can leave it blank. That's up to you. The only instance when we put comma 1 at the end is when we have an annuity due, when the payments happen at the beginning of the period. When it's ordinary annuity, we just leave it with 0. So we have, this is the value of an annuity at if somebody promises you in 5 years, I will give you $100 for each of the next 5 years. To you at 10%, the annuity is worth $379. So now what if we have 10 years? What will be the value of this annuity for 10 years? So what I'm going to do, I'm going to copy and paste this thing here, 10, and I'm going to change the number of years. So the value of this annuity, if somebody promises us for the next 10 years, for each of the next 10 years, I'm going to give you, exactly, I'm going to give you $100 for, this is how much is worth to you, 614.46, exactly. Now, how about so do you notice that we double the number of years, we double the number of payments, but the present value doesn't double, it grows by less than that, because of the discounting function, like is exponentially, is negatively exponentially. So you will see that the shape is negatively sloped. Anyways, let's try now. Let's double the number of years and look at what happens. It did not double, so we have twice as many payments as before, but now the price is $851. Let's double the number of years here. Now we have 40. What do you think will happen? Will it grow by more or less than double? Less. Now let's double to 80. So we have now an annuity that promises you $100 for each of the next 80 years. How much would you pay for that investment? And we will see that is $999.51. What if we double this? Let's do one more. So I'm going to double this to 160. So for 160 years, you're going to be receiving $100 for each of the next. What is the value of this? It's very close. This is not. This is due to rounding, but if you add more decimals, sorry, this other way. It's close, but it doesn't touch 1,000. So it's asymptotic to 1,000. Yeah, exactly. By rounding, it's 1,000, but it's not exactly 1,000 when you add decimals. So do you want to double this one and then see one more? So let's double this one, 320 years. You found the secret to eternal life. And when you add more decimals, it's not this one. So when you add more decimal points, it should be very close to 1,000, but it's not 1,000. So it never touches. But you get the point. No, it's close to 1,000. You're gonna pay close to 1,000. So what this means is that even though we are doubling the time, every time the present value doesn't double. Doesn't double. It grows by less than that. And this leads us to the concept of perpetuities, which is this concept. So the perpetuity is a process, is a cash flow that happens for life. It's like you are going to be receiving this for eternity, 100, 100, 100. So how would you value this? And this is the formula that I would like you to have, is payment divided by the interest rate. So this is the value of the perpetuity. So my payment was 100 divided by the interest rate of 10%. Then when you do that, the value is 1,000. This is round 1,000. So this will be like if you do like 1,000 years or 10,000 years. Well, you get the error. No, it cannot be that high. But you see, when you have, it's very close to 1,000. Still, this is slightly less than 1,000. But you get the point, no? So when this is the present value of a perpetuity, when a cash flow that happens for life. There was a time after the Second World War when the UK issued what they called, an example was consols, which were given to widowers of war veterans, and they promised cash flows for life. So the concept is, okay, what if they want to sell it? What is the value? And then the value is just payment divided by the interest rate. So when you do that, payment over rate, you find the present value of a perpetuity.